Bismillahirrahmanirrahim. Um, Last time we went over just basic understanding of vector displacement, velocity, acceleration. Um, Today I'm going to talk about or do a problem related to displacement. So if you have not seen my previous video, I recommend take a look just to get some brief understanding of what are these three different things we're talking about related to displacement, acceleration, and velocity, and how it's related to vectors. So today we're just going to do one problem related to displacement. So let's begin. So this is our problem number 2. Okay, so let's say if the problem says if a person walks 1 kilometer north, 5 kilometer west, and 3 kilometers south, and then 7 kilometer east, find the resultant displacement. So the first thing I recommend you do is once you read the question, underline or somehow highlight what are the givens, and then somehow either circle it or use different highlighter or different methods to know what the question is really asking for. And that's very important, okay, because there's a lot of times when you can have questions, they give you a lot of information. Maybe it might be related to your problem, it might not, it might be just some redundant information that you really don't need. It just throws you off. And then after you do that, what I typically recommend is write down given on one side, okay, and then plot it out. So let's say we have this coordinate system. We have east on the right, north on the top, south, and west. And let's plot it out. So you start from origin, and each notch here is, let's say, 1 kilometer, right? So first you go 1 kilometer up. That's one here. So let's just call it step A, B, C, and D. Okay. So this is A. We go 1 kilometer up or north in here. So that's A, right? And then it says from here you go 5 kilometer west. So 1, 2, 3, 4, 5. So you basically up down here. So that's your segment B here. And it says you go down 3 kilometers. So you come down to 1, 2, 3. So you come down here. That's 3 kilometers from this point. The south you went, right? And then you went 7 kilometer east. That means you went 7 kilometer right. So you have 1, 2, 3, 4, 5, 6, 7 kilometers here. You come down here and you were right here, which was 2, and then you just come down here. So you coming across, and this is you ending up here. That's your final 7 kilometer destination that you ended here. Okay, so now if you think about this from origin, from here you ended up basically here. Okay, that's your final destination that you end up here. Okay, so now there's many ways we can do this. All right, but let's figure out where we at. What is our resultant? Let's call it R, because that's what we're looking for, right? We're looking for our resultant this distance here. Okay, so I want to take this here, what we have here, and I want to expand this. Let's see how it looks like, right? So let's see, here's your origin, and that's your resultant here, R, and that's basically 2 kilometers here, and this was 2 kilometers here. This was your east, south, north, and west. Okay, so let's call this segment capital B here. This is segment capital A here. and this is your theta that you're looking at. Okay, so just the observation, right? If this is 2 here and this is 2, right, and if you're cutting across it, what do you think the angle theta would be? Now again, think about this triangle, right? When you have a triangle, this is the right triangle, you also have 2 kilometers here and 2 kilometers here. What do you think this theta would be? You know, it's kind of obvious if you think about it, but we'll come back and solve it. But it's you don't even have to solve it. It's just, you know, one of the givens, um, facts when you have these kind of triangles. So all right, so let's begin. So again, let's look at, this is R right here, right? So um, so let's start the solving the problem, right? So what is R is equal? If you look at the right triangle, it's R square is equal A square plus B square. So if you put that in here, so put all this information from here, you can basically see it's 2 square, 2 kilometer square plus 2 kilometer square, that becomes equal, have 8 kilometer square, right? And this equal R square. Well, this is R square, so what should we do to get R only? Well, we're going to do square root of R square, right? On both sides, we're going to do square root of 8. So this cancels out this, so that your remainder is R. And then square root of 8 is what? Square root of 8 is 2.8, right? That's kilometer, right? So that's your resultant here. Okay, so now earlier I asked you about what about theta, right? So some of you probably got it, but let's just solve it, right? So theta is equal, and this is coming from our first problem, right? We did this. Tan theta is equal to kilometer over 2 kilometer, which is 1. So now how do you solve that, right? So tan of what angle gives you 1? If you put that in calculator, you get theta is equal 45 degrees, right? Um, and that's 45 degrees facing what? Facing, if you look at it from here, it's what? Southeast, right? The southeast, that's where the theta is if you look at it, right? Now, so we put southeast. Now here's just, I just want to give one more tidbits of information just to see if it makes sense for you guys. Another way to solve it, just from logic point of view. So this is right angle. This length here, let's call it x, and this length here, let's call it x. If these two are equal, or sorry, let's put it x prime, for example, right? Okay, if x is equal x prime, what happens to the angles? This theta is equal to theta prime as well, right? Theta is equal to, oops, theta prime. If these are equal, and you already have 90 degrees, so altogether should be 180, right? So if you have 180 degrees equal, you already know 90 degrees, right? Plus, let's put a theta plus theta prime, right? Which is basically, they're equal, so you can put 180 degrees you put one, so again 180 degrees is equal to 90 degrees plus theta, so that this means these two angles plus this angle gives you 180, so these two theta plus 90 should give you 180 degrees, right? So now 180 equal 90 plus theta this is equal to theta prime is equal to theta, so we will put 2 theta, right? So now you subtract 90 on each side, you get 90 degrees equal to 2 theta. Now let's divide both sides by 2 just to get theta. So you divide 2 divided by 2, so this cancels out, this becomes 45, so that's how you get 45 degrees equal theta. So there's many ways you can solve this problem. This is just one way to see how we can solve this displacement problem, get our angles, get our resultant. So I just wanted to give you one more example of this displacement today. In my next problem, I'm thinking about doing maybe another, maybe 2 more displacement, but one next one maybe has to do with velocity. So we'll get different exposure. If you have any comments or questions, feel free to send me a comment, and we can discuss any specific problem that you have. Take care. Bye.